All right. I hope the screen is visible.
Yes, it's visible.
Okay, thanks. Okay, so today we will discuss about early warning system. Basically, the idea, we will try to have a closer look about like one critique is available about why early warning system fails, but we will try to understand different sort of challenges what we are having at like science is trying to minimize the gap, and then what about early warning system motivation challenges, other key elements of early warning system, and where we all can contribute in overall efficiency improvement of any early warning system, or maybe for multi-hazard early warning system. We'll also try to understand the details of the dynamics about community-based early warning system and traditional early warning system approach, genesis of early warning system research, and so on. Okay, so just a basic idea of motivation, why early warning systems are important. Before that, we need to understand we all know that disasters affect each and everyone everywhere on the planet, okay, in more or less in different sense. So now the idea is since yes, definitely you can put up your questions in the chat box. Yeah. So the idea is if we try to understand basically in terms of natural disasters, the main concern is the disequality, and that we can see on the screen is if we go by the history in recent past, we can see the around 50% the impact is on low income group, you can say. Also in terms of low income countries, you can relate it with the developing countries as compared to the developed nations as well, because again technologies, the advancement in technology, adoption in technology, and then the delivery on ground with the help of different kind of technology is also vary from a country to country based on its economic profile. In the same way, next one we need to understand. One is yes, the disequality, plus next challenge for us is the one is the disequality in terms of it affects to the low income group and so on. Next one is the women and the children when we talk about the most marginalized and so on. So this is the data available from last recent past, a few of the disasters. So based on that, you can understand how what is the basically ratio. So it's around 1:14 if we try to compare how disasters are affecting women and children more as compared to men and so on. So these are some of the granularities we need to understand to realize or to take an account of why early warning systems are important. So also there are references that the disasters basically they are linked with the climate, weather, including flood, storms, heat waves, and so on, and the disaster damage cost, since we all know that climate and other kind of dynamics will be there in future as well. So there is expected increase in number of natural disasters, and then their cascading impact, and also the damage cost associated with infrastructure, plus the life as well. Okay, now by understanding the importance of disaster management, we'll try to understand what is the meaning of early warning system. So there are various definitions available in literature. How do you define early warning system? And our general understanding of any early warning system is about that kind of a system provides us warning before kind of an event, so that we are better prepared, right? So, and in that case also the picture comes to our mind is a kind of a technological infrastructure, sensing something, delivering information, disseminating information, and then taking some action. So that is the general understanding of early warning system. Whereas in my opinion, and classical literature as well. Early warning system are basically the complex processes, and until unless we understand the complex dynamics associated with these processes, that is very much important to reduce the impact of natural hazards. So why these are processes, we'll try to have a closer look on that as well. And if we definitely, there are cases and the success stories are also available that if we effectively implement early warning system, it can contribute to improve the resilience, to decrease the vulnerability, and also it can support to achieve SDGs, different SDGs with different different magnitude, and it can efficiently reduce the loss of life and livelihood. Okay, now why early warning system? Already we have a kind of idea why early warning systems are important. Let's have a look at some of the case studies in recent past. So one is the modern early warning system helped limit casualties from cyclone Sidir in 2007. If we compare the same event with early warning system and without early warning system, so we can see significant differences there. Same case of Cuba hurricane early warning system, where the strongest hurricane in Cuba is last 50 years didn't result in a single death despite the destruction of 1 lakh houses. So it means some success stories are there related to early warning system, and early warning system can significantly efficiently help us to minimize the impact of different disasters. Also, the value of early warning system can, there are studies available in terms of cost-benefit ratio, where we can improve the gains up to 500% depending on the hazard type and on the overall response capacity of communities. And it also depends on case and location, and then the system itself when we are talking about early warning system. So from this screen, we can understand that why early warning system is important. Now coming to the implementation of early warning system. Before that, what are some of the key challenges associated with the early warning system? And this also comes from the different case studies in recent past. So we understand that even though the early warning systems are having efficient capacity to minimize the losses and damage and so on, but there are challenges. For example, the weak strategies. So once the technology is available, how we are using the technology is also very much essential and important. So what kind of strategies we are following while using kind of any kind of technology. Also the capacities. So when we say the limited capacity, it means if for example, the technology is available, but what kind of potential of the technology we are using, for that we need different kind of capacities, competencies as well. For example, let's say if we all are having kind of smartphones nowadays, but do we really use the power of kind of any smartphone up to the full potential, or maybe the more than half of the potential, or more than 50% of the capacity what the processor and the technology can do? So generally we don't utilize that. Okay, so it means that the capacity or the competencies are also important once the technology is there in place for the meaningful use. Okay, and next is also it involves a wide range of stakeholders. It requires cooperations, because one is the technology part, before that the sensing part, and now since we all understand that the disasters don't follow the boundaries, so it can be beyond any political or administrative boundaries, and for that cooperation beyond these boundaries is important, starting from the implementation designing phase to the delivery phase as well. And in that case, again, different kind of challenges are there. Also, the complexity requires well thought through design and strong institutional capacities, and it also varies from case to case. Similarly, now one example that this is a kind of global early warning system where access is available to climate related information to around 75 countries by 67 early warning systems. So there is integrated framework or a network of various early warning systems. And now when we talk about integration of different early warning systems with each other, definitely for to improve the overall efficiency on a larger scale, there are again different level of there are different challenges at different levels. We will discuss about that also in incoming slides. Okay, then sorry. A lot of other projects related to early warning systems are ongoing in different phases to support the different sustainable development goals. So before going into the detail of the early warning system mechanism and then components and the advances in technology, just to get an idea that how the genesis of early warning system or the advancement in early warning system took place. So the early warning system basically got an attention from within last 20 years. And one reason for that, because the disasters were there before 20 years as well. But in case of early warning system, they are heavily dependent on the advancement in the information and technology, information communication technology. So since there are exponential technologies and emerging technologies growing all together, and the same way it is these technologies are also supporting the growth and the advancement in the early warning system. And then we can see how the progression of early warning system happened in last 20 years with different conferences, discussions, and so on. This is just to get an idea that what is the overall genesis story of early warning system so far. Now, next idea is when we talk about why early warning system. So definitely, when we talk about climate change adaptation by UNFCCC, or maybe the SDGs, or even the Sendai framework, we can find out some. The common thing is that all these are talking about reducing the vulnerability and enhancing the resilience. Definitely, they are linked to each other, but it is much more when we say the reducing the vulnerability. So reducing the vulnerability of the society, and now when we talk about the society means who that also we need to take care, also the physical vulnerability, social vulnerability, and so on. So reducing vulnerability itself is having multiple dimensions and complexities to this objective. And when we see the common objective is the reducing vulnerability and enhancing resilience, this can the early warning system can contribute significantly to achieve this particular objective. Okay, now next is to understand the key elements of early warning system. So early warning system, as we already discussed, that it's not just limited to a system or the technological system, but it is much more than that. And it means these are the complex processes, and we will try to understand the complex associated with these processes now. So starting from early warning system, first component is risk knowledge. It means how we measure the risk, how do we understand the risk. And now the risk means, again, the risk of lives and also the risk of infrastructure. So first thing is, how do we assess that risk? Sorry. So now to go into the detail, we will discuss in detail also. Next component is monitoring and warning services. So how accurately we are monitoring with the, again, setup of different technological services. The same way, next one is the dissemination and communication also the response capability. Once you know like what kind of risk we are talking about or what we want to do with the help of the monitoring and warning services, then what kind of response capability we are talking, and then the dissemination and communication. So to understand this in detail, when we talk about the risk knowledge, it means a lot of things are there in that first element itself. One is the prior knowledge of the risk faced by the communities. So because when we talk about warning, it means we are saying something to someone, okay, and based on that we are expecting some kind of reaction. So in that case, one is, do we really understand the hazard and the vulnerability of that particular community, of that particular area? And again, with respect to particular event or particular disaster, in that case, then what are the patterns and trends in these factors are also important. Now, are the maps and data widely available? So why we are talking about this is because once we know the risk, for planning, we need the detailed information and data to minimize that risk. Now, the components in the warning service also starts from the technical monitoring with the help of sensors, then the network of the sensors communicating with the different devices, and then giving some kind of advanced information. And then are the right parameters being monitored? So now, if we evaluate the case studies, there have been cases like the monitoring instrument is installed at wrong location. So in that case, the uncertainty increases in any early warning system. So are the right parameters being monitored at accurate location with accurate kind of sensors and so on? These things we need to understand. Is there a sound scientific basis for making forecasts? So what any kind of forecast model, if we take, there are uncertainties in these models. Also, it depends on the accuracy. So no model is perfect and no model is 100% accurate. So what kind of scientific basis are there to minimize the bias in such models? Can accurate and timely warning be generated? So this is again the question. Even if we have the established infrastructure, technological infrastructure for any early warning system, the question is, can we accurately and timely generate the warning? So now the accurate means, again, it comes to the limitations of what we are monitoring and how we are monitoring, how we are predicting. And then timely means how much time do we have in hand? And even if warning has been issued, then how much time it will take to react on that particular warning. So these are some of the complexities in the warning service. Next is the response capability, and I already talked about the competencies available. Once the technology is there, but then the competencies to use the technology, and it's not only using the technology, but also like understanding the limits and the challenges of any technology. So that is also very much important. So in that, the knowledge and the preparedness to act by those threatened. It means like how the community basically going to respond to your warning. Once the warning has been issued to particular community, how they are going to behave. So what kind of knowledge and preparedness these communities are having. So do communities understand their risk? Now risk is again kind of relative term, because it generally largely depends on the perception, individual perception. Do they respect the warning service? Definitely. Do they respect the service or warning service? Or there can be issues like even if they know that warning is correct, but they can have other associated liabilities, or maybe be other connections. Based on that, they are not able to act even if they want to act. So there can be different level of dynamics at that time as well. It means like if I am or maybe you are saying something to someone that yeah, this is the risk, and but now it depends on the risk appetite of that particular person, or the risk perception itself, how they want to perceive that risk. Now, do they know how to react? It means definitely the traditional knowledge and the indigenous knowledge is there. Beyond that, like is there a possibility to improve that reaction towards these warnings? How we can contribute in that also. Next is our plans up to date and practice. So next is next component, or the key element of early warning system, is the dissemination. It means dissemination of understandable warning to those at risk. So now the understandable warning is the key word in this sentence, basically. So those who are at risk. So now there can be different layers of communication gap. When we have warning in hand, we want to disseminate it to the community who are at risk. But is it understandable? Is it easy to interpret? Is there a language barrier, or maybe the communication gap, or is there a delay in the time, and so on? So again, different dynamics are there in that. Do the warning reach those at risk? Again, the question, it depends, again, case to case basis for different early warning system. Do people understand the warnings? Do they contain relevant and useful information? Even if you are giving the warning, dissemination is perfect, do they know like what to do in such situations? So is there a training for that? Is there a plan for that which is accessible to the community? So these are some of the questions we need to consider while talking about the overall efficiency or the performance of any early warning system. Okay, now going to the advancement in the technology, since we already discussed that it has been the advancement in early warning system has happened in the last within 20 to 25 years only, and now different components are there even for this technological component. So in technology, in terms of technology, if you talk about it starts with the sorry, observations. So observations means once we observe the pattern or the data, based on that we do the forecasting and the modeling, right? So now what kind of advancement has been there? And now the observing the temperature data, precipitation data, and then large scale climate models are equipped with modern technologies. Next is the remote sensing and GIS system. So it allows definitely to issue the early warning system on kind of for different applications. So the characteristic, it means it is showing you one example, but there are other different applications are also for particular technology in case of early warning system. So the satellite communication, it help reducing the time between the collection of the data and how to issue the alert. So if you want to issue the alert, again, we need different kind of technology. If technology A, for example, internet fails, what is the technology B, for example, the radio communication, and so on. So how we can utilize these technologies. Next is the mobile technology. Now, sorry. Earlier, the case was that the mobile communication or the mobile technology was being used to disseminate the information or maybe the warning. But nowadays, since our mobiles in general our smartphone nowadays having various number of sensors, so there are case and there are early warning systems okay. So now coming to the mobile technology, earlier the mobile technology, or even now we are using the mobile technology in larger case for issuing the warnings. But now, since our smartphones are having various number of sensors, these sensors can also be used as to collect the data, and then this data again can be used for forecasting and modeling to understand the risk or maybe to sense the different disasters. So, for example, in case of earthquake, there are different apps. We'll try to cover that also. Like these apps use your mobile sensors in your mobile, and based on that, a better predictive modeling can be done for earthquake related disasters and so on. So the now mobile technology also being used for to generate the data on a larger scale to support different forecasting and modeling. Next is ICT for multiple sources. Again, information communication technology from location A to location B with the help of device A to device B and so on. So these are some of the technological advances. We will try to have a more in-depth look at the advancements. So now, if we can see on our screen, we can see that in the last 40 to 50 years, we can see there has been a lot of advancement in terms of the accuracy, or maybe to reduce the errors in the observation and the forecast. So, for example, now if we talk about, we can see on the screen the RMSE. The range of the RMSE is given at the y-axis, and the time of advancement at the x-axis. Now, coming to the RMSE, basically, I'll not go into the detail what RMSE is and so on. Basically, with the help of RMSE, you can understand the errors in your observations based on let's say, for example, you are having the observational data, and based on that observational data, you are doing some kind of modeling or forecasting to predict something. So in that, to minimize the accuracy based on the observation to generate the forecast. And if we see this, the trend about 72 hours persistence forecast, there has not been much advancement. But if we talk about the 72-hour forecast, 96-hour forecast, 120-hour forecast, and so on, if we can see, so we will start from case one is the 24-hour forecast. So the RMSE was around 4, and now with the advancement in technology, when we say technology, it's about the hardware and the software together. Software means the better complex models, processes, sensors, and so on. So we can see the advancement now. The RMSE is below 1. And RMSE generally, the lower is better, I mean, in case of RMSE. Okay, if you are interested, you can read more about RMSE, what RMSE is, and how it can be used. So it can be used for to understand the error in different observations. Also, it can be used for different statistical analysis as well, to compare different data sets and so on. Okay, and same way, if we see the 48-hour forecast, so for that, before that, we need to understand the near future and the far future. If we see that the 24-hour forecast, if we consider as the near future forecast, and the same way the 72-hour as the far future, we can see that still the errors are RMSE is higher in case of 72-hour to 120 hours as compared to 24 hours forecast. So now the reason, again, there can be different reasons for this. One is it means like a lot of variables are associated with climate. So for that, we need continuous monitoring, observations, and then fusing it into different models, and then we can do the forecast. So in that case, we can see what kind of advancement has taken place and how the RMSE has been improved over a period of time in last 20 to 30 years. Now, next is one is definitely the advancement in the available technologies. What we are sensing, what we are interpreting, what we are predicting, and how we are delivering it. So the lot of advancement is happening in that. But still, a classical challenge about warning is that the let's say if we are expecting a response to a warning, and it should be kind of an action after so although the response to a warning is assumed to be an action giving the warning yes or no character, right? But in reality, warnings are always perceived as a risk. Now, coming to the risk again, different users can apply their own interpretation of how much uncertainty they attach to the source of the warning and how serious the impact will be. Okay, and this is the classical challenge about the early warning system, and we need a lot of work in this particular domain. Once the warning has been generated, once the warning has been generated and it has been disseminated also, after that, how a particular user of that warning or that information, how they are going to behave or how they are going to react based on different uncertainties, and these are uncertainties varies from person to person. So that is the classical challenge, and so that we need to understand, and we need to consider it in different early warning systems, like how we can improve. So to improve, if we talk about improvement, first thing we need to understand that. So to understand that, through as a part of early warning system process is very much essential. And in case of for example, like how definitely finally a person is going to react, and it always depends on the interpretation, uncertainties, and the magnitude of the impact. Okay, now let's try to understand the complete picture of early warning system advancements, and what are the complications associated with the early warning system. So before that, when we talk about disaster management, so now I'm saying disaster management. So management related problems are generally the problems related with the decision making. Okay, so for example, the urban management or the environment management, or for example the disaster management, it means how the managers are what kind of decisions managers are taking. So when we say the managers, it means the associated stakeholders in the process to facilitate the overall functioning of early warning system. So now coming to this, since the disaster management is again classical decision making problem, like how we are making a decision before, during, and after any disasters. So in that case, now coming to the advancement, if we see, so this is kind of example of peak of expertise and valleys of death. When we touch the peak, it means the expertise are having high value and they are reliable, whereas if there is a gap in the peaks, it means a lot of advancement is still expected and needed as compared to the values or at the peaks. So if we talk about the technology, the sensor technology, the fundamental, the foundation of any early warning system, where we are using the sensors to observe something, right? So once the observational data is there, in that we are having pretty much advancement and high value peak for the observations with the different sensors. So the very much accuracy is available nowadays. For that, then it comes to the forecasting. So once the observation is there, from that observation, what we are forecasting or what we are predicting, we need to understand that. So in that case, you can see it's not the peak of sensor technology is not touching the peak of weather forecast. So it shows what kind of uncertainties and errors are involved when we take the observations and then do the atmospheric modeling to predict any kind of weather forecast. The same way, next, once the weather forecast is available, now you can see even if we use the good high value observations, there will be an error in the modeling, because we are talking about the future based on the present and the past data. So coming to this weather forecast, again there is a gap in the hazard forecast and the environmental modeling. So once the weather forecast is there, with the impact of that weather forecast, what kind of hazard will be there. Again, it depends how we are defining the hazard in that particular area. So what kind of variables we are considering, what kind of uncertainties are associated with your environmental modeling, or maybe in that particular hazard forecast model. So in that case, again, we can see that the expertise of weather forecast again dilutes at the hazard forecast. Now, since still we can see that the situation is better or above average when we talk about observations to the hazard forecast. But at this level, when the hazard forecast is there, coming to the socio-economic modeling or the impact forecast. So once the hazard is known, sorry, what kind of impact it is going to create, or what kind of impact will be there, is having a lot of gap. And in that we can notice, because when we say the impact forecast, it's not about the physical impact, but the social impact or the socio-economic impact on individuals' life. So in that case, we can see a lot of gap is there. Now coming to this, next gap is, one is the impact forecast is very less known, or very much it has been studied in very much limited capacity so far. And when we say that it has been studied in very much limited capacity so far, there can be different reasons again, the data itself, how we collect the data, and how granular we want to go to understand a particular problem related to socio-economic modeling. Next, the gap is about the warning. So in that case also, the communication science is well established. We know like how to communicate from location A to location B, even the distance is very high, how to transmit the information in the real time, right? So that information, that's why in that communication science also, to generate warning, there is a lot of advancement, or high value concepts are there in case of communication science to generate the warning. But again, there is a gap. Once the warning has been issued, how anybody or the users are taking a decision. So it depends on individuals' behavioral psychology, and there are gaps. So now if we try to understand the overall picture, we can see that in terms of science and technology for society, we are doing very good at the observation technology, but there are gaps in the weather forecast, and these gaps are the challenges in terms of what we can do to predict for the forecast and the modeling. Then very good, we can do a good kind of hazard forecast, but then the impact forecast or the studies related to impact forecast or the advancement in the impact forecast are very much limited. Then the communication science has grown very well to support the dissemination phase of any early warning system, but then again very limited sorry, literature or maybe the technology is available at the decision level of a particular person or a community in terms of early warning system. So from this we can understand that what are the gaps, what are the advancement in terms of different technologies. Okay. Now just to understand, maybe what we can do is we can take a few quick questions so far what we have discussed, and then we'll go ahead. Students, please, if any question or concern you are having, we can take that. Any questions?
Can I come in, Ravinder? Can I ask a question?
Yeah. Yes, please.
So you were talking a lot about, the society and the way the society will take in the technology. So two kind of questions arise in my mind. That is there a difference in the way we look at these warnings in countries from the global south and the global north? Is there a gap in that way? And also in the urban and rural space. I think rural you covered a little bit, but if you could identify that, what are the gaps in the way these warnings are understood in an urban setup and versus a rural setup, and what are the challenges there? So that will be helpful. Thanks.
Okay, I'll try to cover that as well. Other questions, please, students? Okay, we'll try to cover that also in the coming slides. Okay, so before that, just to understand, it can be considered as a good reading for this class for the students, that the Belgian flood early warning system. So it starts from, for example, the observation. So observations we are doing through different sensors. So what we discussed in the last slide as well. One is the observations. Observations can, for example, for the flood, we can observe the flow on the ground with different flow gauge systems. Now, the first challenge is, how do we know, or how accurately we install these flow gauges at different locations, or what is the distribution of these flow gauges, at what scale, or at what distance these flow gauge systems have been installed, and how much time these flow gauge systems take to send the information so that it can be used for particular weather forecasting. That is first challenge. Next one is the rain radar. So what kind of radar system we are using, what is the capacity of that radar system? It also varies from one early warning system to another early warning system. Where is the location of that radar? That radar, is it again that particular radar, when we say the rain radar, how many variables it is able to capture, for example, the humidity, temperatures, and so on. So these are the observations we take from the observational data through different sensors. Then it goes to the forecasting model. Okay, and in that forecasting, again, what kind of different models we are using. So when we say that we are going from one level to another level, always there is kind of errors are present, and that errors can be, one is it can be the typical measurement error itself, or the another error can be where we are doing the measurement, and are we considering the uncertainty of different locations and so on. So these are some of the things, but in general, it has been taken care in different weather forecasting model, but we should know about what are the challenges associated with the observations network as well. Next is, once the weather forecasting is there, what kind of models we are using for the weather forecasting, how we are disseminating the information. Now, in that case, one is we can use different kind of communication media. One is through internet. Second can be your different communication channels and so on. Then the media itself. Next is the waterinfo.b. This is the interface for this Belgian flood early warning system. You can access this, and after accessing it, you can understand the overall functioning of this system. Next is, so in the center, we have emergency coordination team. So now the team of, we can say, the multidisciplinary experts is working together at different components of a particular early warning system. And then the threatened community. Now the question is, one is the measurement, the challenges associated with the measurements, and then the forecasting, and then how we are disseminating the information or the warning at what level. And then coming to the how we are considering the role of threatened community. When we say the role of threatened community, it means once the warning has been issued, how they are supporting the early warning system. Until unless that support is there, support, again, there can be different issues or different challenges for good support or for not so good support from the community. Okay, so this is from this Belgian flood early warning system. We can have a look. Maybe in your free time, students can go through the detailed reading. I'll provide the detailed reading for this particular early warning system. Now, how we use the mobile technology for early warning system. I think we all know that different kind of mobile apps are available from different agencies for different locations, also for different hazards. And so I'll not go into the detail, but maybe if you want to go into, if you are interested, you can explore that in your available time. So one is the emergency from American Red Cross app, that is kind of very good features are available in this app. Also, a kind of toolkit is also there with different functions you can do. And also next is the disaster app. It is kind of multi-hazard early warning system. The same way, the different agro-meteorological early warning systems app are available. So in this particular session, I'll not cover these apps, how they functions, what is the mechanism behind these functions, and so on in detail. But it will be good to have a look at these apps in your available time. Okay. Now, coming to the question is, once I have already discussed a lot about the limitations of technology, then the advancement of the technology in recent past, what is early warning system, why these are important. Now, the next question is why early warning system fails. So now coming to the participants, maybe you can add few observations based on your understanding. Any random thought is welcomed. Why early warning systems fails? It's an open questions. You can respond to it based on your observations. First question is, do you think that early warning system fails? And the answer is yes. Now the next question is, why early warning system fails? Anybody? Nobody wants to say anything, or nobody is listening anything?
No, I think everyone is listening.
Okay.
Guys, please unmute and you could say.
I think one could be lack of understanding
Sorry, lack of
understanding.
Lack of understanding of
information coming out of the system, or lack of
okay. So understanding. Okay.
Of the video.
One. What else?
The people don't always pay complete attention to the warning. Sometimes they do not consider it important, and they consider it as something which is not a warning, but just an incident that is happening.
So why do people do that? So what you are saying is important, but why do people behave like that?
Because maybe they have received a similar warning before and it did not pan out. So they consider it is not going to pan out this time either.
So that is one. What other reason can be there? Why I'm asking, because it is important and valid point. And again, we discussed that it is a classical challenge also. So what other dynamics can be there for that? What you are saying?
Ravinder, there's one from Denise in the chat box. Due to missing points while conducting need assessment.
Due to missing points while conducting need assessment. Very good point. Yes. Yes, Ahmed, you want to add?
Yes, thank you. As I believe, early warning system needs a good analysis and good historical data that the system can rely on to have indicators to find out when this event could be a disaster, or this event can affect people. So if the analysis or the historical data is not enough, or it wasn't an efficient analysis for that could result in having a fail in that system.
All right, so it adds to the first essential component of early warning system, that is the risk assessment. So how do we assess the risk? Basically, how do we understand the risk? All right, anybody else? Others? Shall we go ahead? Okay, using mostly public channels might decrease the failing of early warning system and be more trustful. Okay, next one is the cost associated with running the system. Okay, all right, good. So we will continue with the class. Okay, now whatever you have discussed are most of them are valid point, but now once we know that these are the reasons, next challenge for us is to understand the reason behind these reasons. Okay, so coming to that, few of the points, the detailed readings maybe I can share so that you can read in the details. Okay, next is one is the legal and the institutional arrangements. When we talk about, and it comes to once the warning is there, how we are going to disseminate the warning. Okay, and there are different reasons, like and that is not because of the technology, but because of who are taking the decisions basically. For example, one case I came through is that the warning was available, and then different kind of political dynamics were involved, and they thought that it's not a good idea to release the warning because it can create a kind of unpleasant situation in that particular community. So they hold the warning to them only, and they didn't release the warning at all. So it's kind of a decision-making problem. Even though we have the warning through different kind of technology, but we are not releasing that. So different kind of arrangements, legal and institutional arrangement. Next is the technology, what we already discussed, like what kind of infrastructure we are using. Then the forecasting capabilities in the developing countries. So forecasting is not kind of easy task, and when we talk about the forecasting, means the impact of hazards and so on. So in that case, what kind of models? For that, again, you need a large scale of infrastructure of technology so that you can do better forecasting. So we have limited forecasting capability in developing countries, especially. Next one is the human resource and the expertise. Now, next is for example, the disaster managers itself, like the limitations of human resource and the capacity or the competencies for early warning system. So expertise means when we say expertise means that we need kind of set of experts who can understand the meaning of the machine. I mean, it means what is the meaning of the forecasting, but what will be the impact of that forecast, and that impact by considering not only the physical space, but also the social space and the community living there, people living there, how they are going to behave, what can be the better approach towards that, and so on. So that kind of integration, we feel still there is a gap in case of when we talk about human resource and the expertise in case of disaster management. So there are different teams, like team A is for technology, and then team B is for the society. So that integration of these two teams is very much important, and there are gaps in that. At different levels, it can be at different for different cases. The next is addressing impact of climate change on disaster risk. Now, one is considering the different disasters, but how accurately we are considering the impact of climate change on these disasters. It means the disaster A in itself, plus the disaster A, plus the climate change impact. So there will be a kind of different kind of impact on that. So how much the component of climate change we are considering? We understand in general that because of climate change, the intensity and the magnitude of different disasters or the risk is going to increase. But in that case, further, more detailed granularity is required so that it can add to the effectiveness or the efficiency of any early warning system. Next is the public engagement. And again, it varies from location to location, society to society. Next one is empowerment. So when we talk about empowerment, the question is, once the warning is there, and do we have plans for that? Like, let's say, so anybody in the community, so once they know, even if the communication gap and everything is taken care and the message is reaching on time, then what are the options and what are the plans available to act to that warning itself? And in that case, do our warnings and the plans consider that what we discussed in that first slide? First slide means disasters affect everyone at different locations differently. So that the differently component is how we are considering that. It means like the marginalized, or the maybe the females and the children, and then the lower income group and so on, how they are being considered in any kind of plan. Okay, so that information itself is missing in most of the time when we talk about the early warning system for any community. Next is the response coordination and the disaster preparedness. And already discussed that the key point is the finance. So definitely the finance is the main component here. If finance is not a problem, we can use kind of very much advanced technology, very much good facilities, forecasting and so on. So the key challenge remains the same, and that is the finance. Considering that challenge, then what other kind of challenges are associated with early warning system? So these are some of the challenges what will be discussed in here, and later on maybe I'll share the reading so that you can go into the detail if you are interested. Okay. Okay, so how much time do we have?
Ravindra, up to you, but another 15-20 minutes.
Okay, all right. Yeah. Okay, next is now, since we understand about what are some of the key components of early warning system, what are the advances and challenges associated with the performance of early warning system, some of the good case studies I'll share just so that you can look into them in detail whenever time allows. So this is impact-based multi-hazard early warning system. And why the multi-hazard early warning systems are important? Because now we are talking about the disasters, or maybe the natural disasters plus the climate component. And if we are not integrating these two things, then our warnings or the forecast itself is not going to make sense later on, because that climate component is by default integrated nowadays in any kind of disaster related event. So for that, this Georgia Global Climate Fund Project 2018, you can go into the detail and you can read about it. So now in this, what kind of hazards have been are being considered, what kind of modeling has been followed, and what is the different the basic process of. So for example, we will start with the monitoring, warning, then the risk knowledge. So for the risk knowledge, what all components you need. So for example, now coming to the risk knowledge assessment, it starts from the data collection, again with the observational sensors and so on, then the hazard modeling. Next one is the hazard assessment and the mapping. And in that, what is much more important is the socio-economic vulnerability assessment. And in most of the plans, this component is still missing in disaster preparedness plans and so on. Next one is the GIS-based socio-economic risk and vulnerability models and so on. So it has been considered, and now it is also, you can see in the upper right corner that additional data sources. It means the accuracy of the data is also being improved with the integration of different data sources and so on. And next, then we generate different level of warnings, level 1, level 2, level 3. Level 1 means the alert, level 2 is get ready, and level 3 means the note act immediately and so on. Okay, so next, sorry, So for example, now the basic framework, and now you can think yourself that what kind of challenges are associated at different levels when you talk about level 1 warning. Level 1 warning means we have 48 hours available in our hand. It means we know that what is going to happen before 48 hours, so we can generate a level 1 warning as an alert that be aware. So for that, now you can see what kind of different functions operational center is having. It means the communication, right? So communication, what kind of different media we can use, because we have time in hand, so we can use telephone, mobile phone, sorry, even the email, or we can use the internet, TV, radio also. Now just try to imagine if the situation is like you don't have 48 hours, but you have only 5 hours, or you have only 1 hour. Because every time, since we understand the complexities associated with natural disasters, every time our systems cannot predict everything before 2 days or before 48 hours and so on. Okay, so that challenge still remains. For example, in case of tsunami, we cannot minimize the time. The same way in case of earthquake and so on. So based on that, now you can just think about or pen down about your location, that what kind of challenges people face or the community face at a different level. So for example, now the operation center, so the communication will go again, some authority needs to approve it, otherwise people are not going to believe it. But now how the local authority is reacting to that information? Are they communicating the same what they know, or they are hiding some information, or maybe they are exaggerating the information? So these are again the decision related scenarios, how the local authority is behaving once the warning is there. Okay, and next is then how the community is going to react to these level 1 warning. Since we are saying that it's just an alert, so it means now it depends on the risk appetite of particular person, or maybe the behavioral psychology, how they are going to act. Somebody may take it serious and they start planning for the plan B and so on, and somebody may not worry at all about that level 1 warning. Now next is the level 2 warning. At that time, it means the alert to be prepared has been issued, and for that again the same channels can be used also. Now since we have very limited time, you can see the advancement. It means we need extra channels of communication so that we can convert it from a warning to an alert. So for that, different kind of technology like the siren boards and bells and so on also can be used in the community. Again, it comes to that, like when we are generating the warning, means how the local authorities are acting in particular case, and then how community is responding to these warnings. So it generally we consider it as the level 2 warning. The same way, the level 3 warning, it means we need to take action right now, and we don't have time in hand. So for example, the cyclone landfall. So once the landfall happens in any case of very severe cyclone case, at that time, how the operational center is going to behave. So in that case, again, different kind of technology can be used, how the local authority is behaving, and then how community is responding to that, plus what kind of the emergency plan from different groups we are having. So that is the level 3 warning. Okay, now once we know that the level, there are different levels, and in these different levels, level 1, 2, 3, there are different levels again, means how things are panning out on ground. Once the warning means the information is there about the event, or maybe the hazard location is known and the impact is known, then how the local authorities and the community is going to respond to these warning is kind of very crucial and important part of effectiveness of any early warning system. So Next is the IT for emergency response. So now this means like how we can use different technologies nowadays to improve the response of the community, or maybe to uh, uh, to improve the response of the community, or maybe the involvement of the community in taking different decisions and so on. So for that, I think we all know that there is a function of crisis response, and Facebook use it. It means anybody can mark he or she can mark himself or herself as safe during a particular event, maybe flood or heavy rainfall and so on. And then these information can be used in real time to take different kind of decisions based on the severity of the situation. And so this kind of IT related framework can also be used for emergency response. Next is this is kind of take home exercise. You can explore this meteor alarm also. It is kind of the good kind of example of an early warning system, and it is implemented throughout the Europe. So you can just check about the different capacities, functions, and so on. We know our main 4 key components now. So based on these 4 key components, you can review this overall early warning system. Now, coming to next point is what are some of the pillars of early warning system. So we know the component of the early warning system, but the success of early warning system depends on 3 main factors. One is the institutions. So the establishments, what kind of, when we say the establishment, it means again the hardware, software, and the human resource part as well. Next one is the civil society, means how we can use the response or the help, or maybe how we can involve the civil society to improve the overall accuracy of warning dissemination. Then the instrumentation, what kind of alternative for the instrumentation, since we cannot install sensors and we cannot generate observational data at each and every location. So what can be the alternate to these challenges? For example, we cannot install the gaze stations at each and every location. So what can be the alternate to that? And let's say even if we install the gaze stations, and these gaze stations transmit the data in real time to the operation centers, but let's say that the communication channel is not functional at a particular event at that time. It means we cannot get the data to predict something or forecast something. So in that case, what we can do? These are some of the things we need to think and consider. Next is about the 2 conceptual framework for early warning system. One is traditional, means you do the monitoring and you issue a warning and done, right? Another one is end-to-end. It means another one is end-to-end enhanced view disaster preparedness. It means once the warning is there, then what kind of plan you are having so that you can maximize the efficiency of any early warning system. So generally, we need to go beyond the traditional view of the technical agencies that the warning is there and it has been issued with whatever mode of communication we are having. Before that, in addition to that, what is very much important is the anticipated response. It means we need different scenarios that how a particular community or that particular area where the warning has been issued is going to respond. And in that response, how we can improve So in that response also, how we can improve the overall accuracy of their participations and so on once the warning is there. So in that case, since we all know that the success or the failure of early warning system basically is measured in terms of people saved and the loss is minimized. That means the loss means the infrastructure loss also. So how we can improve, what can be different alternatives to that? So definitely we need plan B at for each and every component. It means when we say the risk, it means one is the traditional approach of risk assessment using different set of technologies, plus what can be the plan B? It means like how community generally behaves to these kind of risk and so on. Is that information is also integrated in our early warning system for particular community? The same way, are they aware or not, and so on. Next one is the in case of monitoring, can we have plan B in case our technology fails and still we need to monitor for the forecast? So what can be the plan B for that, and so on? So there are different solutions available. Some of them are highlighted on the screen. For example, we can use simple instruments or low cost affordable technologies for different kind of sensing instrument, and then it can be integrated at various levels and so on. Then the communication platform that is people friendly and multitasking, so for that different technology can be used. Also the drills and the improvement emergency drills or the test can also be used to improve the emergency plan. It means the awareness component. And it's not only about the impact of that particular hazard, but the awareness about different scenarios. Let's say scenario 1 and scenario 2 and scenario 3, then how should people respond to different scenarios? We need a lot more in terms of awareness. The awareness means the training of the community for different scenarios and for different disasters and so on. Okay, then what kind of community, how we can improve the community participation? So for that, maybe I can share the readings also, and how we can improve the community participation so that we can improve the overall accuracy of the early warning system. Because participation is also important. Let's say the technology generally the connected through different ICT tools and so on. In case of these ICT channels or tools fails at that time, also how to prepare the society for to take or to react to that particular warning in that case. So for that, different plans can be prepared on case-to-case basis. Okay, so I'll stop here so that we can discuss your observations and we can take few questions. Thank you. Maybe we'll take few questions, please. This was just to give you an idea about the early warning system and so on. Maybe we can cover later on in your other modules about how particular early warning system, the in-depth understanding of particular early warning system, so that you can do more reflections on that. Yes, class, please. Comments or maybe any question or any observation. No.
Thank you very much. It's very, very informative. I posted a question earlier on about an example of successful implementation of EWS in case of unpredictable natural
Can you be a
hazards,
bit louder, Sachin? I can't hear you clearly.
I'm sorry, my microphone was away. I'm so sorry. So I was just saying, I posted a question, I think a few minutes back, or I think half an hour back, about some examples of successful implementation of this EWS in the situation or in circumstances of more unpredictable natural hazards like earthquakes. Because a lot of work has been done or is being done recently on mapping out the shallow falls, especially in the north and upper Himalayas region. And I'm just talking from India's context. what do we do in a situation where it's so unpredictability is high? People are still working in creating some sort of ecosystem or some sort of a overall monitoring and monitoring system, and then linking it back to the society and community, and then all the information that you would gather. You talked about data and so on and so forth. So, is there anything that has been done for such hazards is first question, and then how do we prepare ourselves? What would be your thoughts, and especially in context to India again, where not much is being given so far to resilience of infrastructure that we have been building over decades and decades. So any thoughts on that would be really helpful. Thank you.
All right, all right. Yes, what you are saying is in case of India, I'll say that the general idea of like reacting to disasters in Indian scenario has been is like once the damage is done, then we try to learn something from that event. But the challenge comes now is no two disasters or two events are similar to each other. So the learnings from let's say the event one can definitely help you to better preparedness, but it doesn't mean like if you are preparing a plan next time, if the event two definitely will be different at that time. These learnings can help you, but if you are preparing based on these learnings only, then there will be a challenge. So the proactive assessment is very much important. Now next is what we are doing right now, and any success story. So in case of Himalaya, definitely still challenges are there in terms of we discussed already about technology and so on, but now in recent past, because of the landslides and the earthquakes and so on, few institutes, for example, I'll say IIT Roorkee, sorry, they have Center for Excellence in Disaster Mitigation and Management. So they have installed a early warning system in that particular area prone to that. But again, I'll say that installing sensors or installing early warning system, sorry, at different locations is just a kind of very small step or small contribution. Because now question comes, one is, do we really have the mapping of the physical vulnerability? So let's say if we have the mapping of the physical vulnerability, again, the approaches has been used so far to map the physical vulnerability at different locations in India is questionable. Next is, do we have social vulnerability map? That is also not there. Next is, let's say, even if we know that this area is highly vulnerable and people are living there, but what is the plan B for them? So I'll say just that again, the key understanding is early warning system or is not kind of a linear process. So it's very complicated, and we need to look into different dynamics. So this dynamic starts from the technology plus who are living, where we are installing, what we are doing. So it's complicated. So in case of success story, my understanding, like we are doing a bit, but not holistically. So we cannot say that there is a particular case where we have done wonderful work. I say that different institutes are doing in their capacity. Sorry. So for example, in Himalaya, different institutes, around 5 institutes are there, and they are doing good work, again, in their capacity, in their understanding. But we need a larger kind of approach to deliver something effective on ground. So I don't think like currently we have something to say that yes, we have done very wonderful job. But yes, definitely in case of Indian Ocean tsunami warning system, I'll say that this is kind of a state-of-the-art contribution. What early warning system we are having so far is kind of because considering we need to consider the challenge of technology also when we talk about the future. So in that case, I'll say that the early warning system related to Indian Ocean tsunami is still a state-of-the-art system along the coast, but I don't know much about the Himalayan part, like how much we are able to understand that, because even geologists say that what we know about Himalaya is again very limited in terms of science of that Himalaya itself. So there are challenges associated, and we need to do a lot. I don't think like we have something right now which can be considered as a good case.
Okay, thank you very much.
Yeah.
Great insight, and I agree. Yeah, long way to go, but I think people have started doing work, and we've been working with
Yes, yes,
Cambridge, for
yes.
example, in looking at mapping out, at least shallow falls, and creating some sort of an inventory, and also
Mhm.
installing some monitoring devices across this region in the belt. And we've seen a recent earthquake just
Right.
happened a few days back in Nepal. So yeah,
Mhm.
all really good. We are heading in the right direction, I think. Thank you.
Yes, yes. Thanks. Others, please. Any observation, question? All right, good. Maybe my suggestion is few of the readings I'll be sharing through Soumya, and you can go through them in detail. Soumya, over to you.
Thank you so much, Ravinder. Thank you for such an interesting session. And I hope there were some very good questions also from everyone, and the interaction. Thank you so much, everyone, for participating and spending your weekend. Thank you, Ravinder, for taking out time.
All right.
Right. So you can definitely get in touch with Ravinder on the reading material I'll share with everyone. I'll also share his email ID. So if you have any questions, queries, you can definitely get in touch with him. He will also be your faculty for module 5 in the coming months. So there will obviously be more interaction with him on that module as well. So thank you so much, everyone.
Sure.
Just a reminder to everyone, Tuesday we have another class on conflict assessment and conflict analysis. So please take out time if you can for that session on Tuesday. If you are facing any problem in terms of the timing, considering it's a weekday, do let us know in advance. We also have a session next Saturday at the same time as today on gender as a cross-cutting issue. So please do take out time. Our colleague Lavanya Arvind will be taking that session. So thank you so much, guys. Have a nice weekend. Thank you.
All right.
Thank you.
Thank you. Thank you, Soumya.
Bye-bye.
Thank you.